Hello, pre-calc students. Today we're going to learn how to graph parabolas. I'm sure you guys have seen parabolas before, but today we're going to do things a little bit differently. Let's talk about what a parabola is. A parabola is the set of all points that are equidistant from a fixed point, the focus, and a line, the directrix. All right, so as you can see over here, we can have parabolas that open vertically, meaning up and down, or horizontally, meaning right and left. And we're going to talk about what helps us determine whether it opens up or down, right or left in a second. Okay, we have one little mistake that we need to fix here. This should be K and H. And the center of the parabola, or the vertex right here, is always at HK, similarly to what we have seen before. Okay, so if you guys notice, we do have this variable P inside of our equation. P is the distance between the focus and the vertex, and also the vertex and the directrix. So this is a distance of P. We use this constant value here to help us find out P so that we can find and plot the directrix and the focus of a parabola. Also, we can use P to help us find another point on the parabola that we can reflect across this axis of symmetry that we have here to find a point on the other side. One thing that we should know is that since all points are equidistant from the focus, a point on the parabola here is a distance of 2p away. All right. How do we know whether a parabola opens up or down? Okay, so if a parabola is vertical, we're going to notice that the x minus h term is squared. And when we find out that p-value, if p is greater than 0, the parabola opens up, and if p is less than 0, the parabola opens down. Similarly, for a horizontal parabola, we see that y minus k term is squared. When we go find out what p is, if p is greater than 0, it opens right, and if p is less than 0, it opens left. And p is the distance from the vertex to the focus, and also the directrix. We said this, but didn't write it. All right, let's look at some examples. Let's just get right into it. All right, graph the parabola, make sure to include the focus and directrix. First things first, we're going to decide, does this parabola open vertically or horizontally? And we can see that we have the x minus h term being squared. Therefore, this parabola opens vertically. All right, let's decide if it opens up or if it opens down. So I notice that this value is 8, and I know that the form of my equation I have tells me this is equal to 4p. So I know 8 is equal to 4p. Therefore, p is equal to 2. Since p is greater than 0, I know the parabola opens up. And now I know the distance that I need to go from the vertex to find the directrix and the focus. Let's find out what the vertex is. The vertex in this problem, is going to be at 2, -1. 2, -1. So I can go plot the vertex at 2 over down 1. There's my vertex. And I know it opens up, therefore the directrix is going to be behind that minimum value. And I know that the directrix is p units away. So since p is 2, I'm going to just count down 1, 2, and draw in that directrix there, going the opposite direction. If the parabola is vertical, the directrix is horizontal. Oops, that is not 2 units away. I apologize. Jeez. 1, 2. All right, and I've got my directrix then. And my focus point is 2 units above. 1, 2. So I've got my vertex, my focus, and my directrix. And now I just want to use the knowledge that a point on the parabola is 2p units away from that focus. If I go out in either direction, directly off the focus. So if p is 2, 2p is 4, and notice 2p is the distance from the focus to the directrix. So we're going to use that knowledge. All right, we're going to go over 4 units. 1, 2, 3, 4. And there's another point along that parabola. And 4 in the other direction. 1, 2, 3, 4. Oh my gosh, I cannot count today. 1, 2. Okay. And now I have 2 points to anchor down my parabola, and I can go ahead and draw it in. We've got our directrix, p units away, our focus, p units away. This is vertical, opening up since p is greater than 0, and then we use the fact that we've got a distance of 2p from focus on either side to the parabola. And that's it. Let's look at the next practice problem that we have here. All right, in this one, I notice that the y term is being squared here. So that tells me that this is a horizontal facing parabola. Okay, let's find out what p is. I notice that this value in front is -1/4. I know 4p equals -1/4. So if I multiply both sides by 1/4, I get p equals -1/16. That's a pretty small value, so we're going to just do our best to approximate here. However, this does tell me that since p is less than 0, the parabola opens up to the left. All right, let's find out where our center or our vertex is located. Our vertex is at 3, 0. So 3 over, 0 up. Okay, this can be a little tricky because 1/16 is very small. This is opening to the left, therefore I know I'm going to be facing this direction. So the directrix is behind. 1/16 behind. Oops, sorry. So we're going to just make it as accurate as we can. Okay. And the focus is 1/16 in front. And if I want to find another point along the parabola, I can say 2 times 1/16 is 2/16 or 1/8. That's the distance I have to go off of the focus until I hit the parabola again in either direction. And this is really small, but that's okay. We can make it work. This parabola is just skinny. Close enough. We've got the vertex, we've got the focus, we've got a point, using reflection get this other point, and the directrix behind. A distance of p, a distance of p, a distance of 2p, even though it's hard to tell because it's really tiny. All right, so why don't you go ahead and try your turn A. Go ahead and pause the video right here, attempt to do this problem on your own, and then when you're ready, go ahead and hit that play button and see if you got it right. Okay, so you should notice that the y term here is being squared. Therefore, we have a horizontal parabola. I've got 4p equaling to -4, and I find out p is equal to -1, which is less than 0, which lets me know that the parabola is opening to the left. The vertex is at 3, +2. So I can go ahead and plot that at 3, positive 2. I've got a distance of 1. 1 behind gives me the directrix, 1 in front gives me the focus, and then a distance of 2p on either side of the focus gives me another point on the parabola. All right, your turn again. Try it out. Go ahead and pause this video and see how you do. Okay, you can see that x term there is being squared, which lets me know that the parabola is open vertically. I've got 4p equaling 1/2. So p has a value of 1/8, which is pretty small. This tells me since it's greater than 0, the parabola opens up with a vertex at 3, -1, 3, -1. I can go ahead and plot that 3 over down 1. We've got a distance of 1/8 until we hit that directrix. I've got a distance of 1/8 until I hit that focus, and a distance of 2p on either side, which would be 1/4 until either side of the focus, which would be 1/4 until I hit the parabola again. And so I can go out that distance, and then I have my parabola. It's a little bit skinny, but it still works. Okie dokie. All right, so it's up to you to complete these practice problems for homework, and then we'll go over them together in class. Make sure you graph the parabola, include the focus, and also the directrix. Bye.